I think this will be fun. Host and server IP configuration and testing tools. Now, you would think that this being a Cisco certification training, we would only see Cisco stuff, meaning router configs and switch configs and concepts and so on and so forth. That's just not the case. It's actually on the certification exam, it's not the case. In the real world, it's not the case. It'd be nice to be in our Cisco only bubble, but there are devices that we have to support, and you will have to know how to work with those devices. And the most common device that you're going to run into is the Windows operating system. So what we're going to do here is actually, first off, go to a simple concept, which is setting static IP addressing in the Windows operating system. Then we'll go through a gamut of Windows testing tools. I'm going to actually start with my favorite first, with Wireshark. Well, let's start out by talking about Windows. Now, Windows, when you install Windows, whether it be Windows client or server, and you just go next through the installation process or pull it out of the box from the store, both of these devices are going to have their network card set to DHCP by default. What that means is they don't actually have an IP address. When they boot up, they will send out a broadcast message to the network trying to find a DHCP server out there somewhere, which could be a variety of devices, who will send them an IP address so that they know what network to work on. Now, one of our tools as a network admin is we may need to change that to a static IP address because sometimes we may want to know exactly what IP address our data is coming from. We may have a filter applied to a certain address. So knowing how, whoa, scroll wheels, knowing how to set a static IP address inside of Windows is absolutely key. Now, I'm in Windows 7, Windows XP, Windows 2000. Everything has been the same until you get to Windows 8, which probably has some touchscreen box that you click on that goes in and sets the IP address. Now, I'm really trying to fall in love with Windows 8. I just can't yet. So I'm sticking in Windows 7. We've got, so I'm in the control panel, right? Start, control panel. View network status and tasks. And I see, well, up here, upper left, change adapter settings. There's my two network cards that I have. LAN 1, I actually named it that. It's normally called local area connection. Local area, yeah, I think so. That or local area network connection, spelled out. So I named it LAN 1 because I add more network cards in some of my series. Is my real network card. Next to that is VirtualBox host only network. VirtualBox is a free version of essentially VMware, allowing you to do server virtualization on a workstation, which is really nice. So I can see them right there. So I'm going to go to LAN 1, right click on it, go to properties. There's my TCP IP version 4, go to properties, and I can see this is all DHCP. How do I know? Because it says right here, obtain an IP address automatically, get your DNS servers automatically. That essentially, all the automatic is a pretty name for DHCP. So if I go to a command prompt, and I usually just hit start run, I actually click on my keyboard, the Windows key R, brings up the run box. I've got the command prompt, make that a little bigger, type in ipconfig. Right there I can see there's my VirtualBox, my VMware equivalent, but right up here is the one I care about, LAN 1. All this stuff below, by the way, is all IPv6 related. We'll just skip that for now, but LAN 1 is my real network card, and I can see, okay, it has the IP address 172.3100.188. Well, they must have gotten that automatically because I can see over there on the left that something, that's what it's set to do. So let's do an ipconfig/all. And I'll find out that if I scroll back up, the DHCP server that gave it that address is 172.30.100.1. Now, that is actually my router/firewall that I use for my office. So that is not only the default gateway, the router/firewall, but it's also the DHCP server. I told you a whole variety of devices can hand out IP addresses. It is actually a device from Ubiquiti. I think it's called a fast router. I mean, some generic name. Really fun company to play with. Anyway, nonetheless, it's got this IP address. I can see it's got some DNS servers assigned to it via DHCP. All this stuff just came automatically. Now, I want to jump right into a tool that I would consider very handy and very useful to get to know right away. Wireshark. Wireshark is a free utility. Just go on Google, type into Wireshark. It used to be called Ethereal, allowing you to watch all of the network traffic that's going to and from your Windows PC or Macintosh PC or Linux. It's cross-platform, right? So I will tell you, the faster that you can get familiar with Wireshark, the better it will be. Matter of fact, Keith Barker at CBT Nuggets created an entire series on Wireshark. You might just go take a look at the first couple videos in there. I'm going to give you the flyby overview of this right now. So I'm going to go in here and say, I want to capture some data from my network card. And it says, okay, well, what network cards do you want to look at? And there's my virtual box, LAN 1. I'm saying, well, LAN 1, I can actually see packets being sent and received. So I'll click on Start, like show it to me. Show me what you're doing, network card. And so I can just see stuff happening behind the scenes. There's some ARP messages. I told you earlier in the series, you'll see a lot of those when you're watching the network. But I'm going to come to my command prompt, and I'm going to do an ipconfig/release. Now what that does is give back the IP address to the DHCP server. And you can see now LAN 1 is blanked out. There is no IP address information. So I'll say, well, why don't you go ask for a new one, ask for a new IP address. So it's going out there and it's saying, hey, I need an IP address. Now behind the scenes, all kinds of stuff is happening in Wireshark. And you can see it got the same one back, 172.30.100.188. Okay. Well, let's stop the story of Wireshark behind these. Stop the capture. You see, I click the stop button. Now, with Wireshark, let me first off give you the basics. Your information is divided into 3 panes. And we've got the top pane, which I would call the packet summary. Gives you kind of the big picture details of what these packets are. Down below right here is the details, and it actually breaks it down by layer of the OSI model. I'll show you that in a second. And then down at the bottom, I would say is probably the least useful information. This is a hexadecimal dump. Now, I'm not saying it's not useful. It can be useful, but I would say compared to the stuff up top, not as useful. So one of the biggest things that you'll want to get to know first with Wireshark is how to filter this data. Now you can see, I mean, I just had this running for what, 30 seconds, and we captured 800 packets. That's a problem. Not for the computer, but for us, because we're like, I wanted to see the DHCP action. I wanted to watch that occur, but now I've got all of this stuff to tread through. Well, if you know what you're looking for, you can actually manually create some filters by hand. You can see that up here. But if you're just scrolling through, you're going, okay, where's the DHCP packet? I'm looking. Oh, did I see one? Yep, there's one. So I just see right here, protocol, DHCP. So I just grabbed one, right? Now, one of the quick ways to filter your data is to say, I just want to see this DHCP information. Now, looking at the second pane of information, this is by OSI layers, the data inside of that packet. So I clicked on the DHCP inform message, and I can see this is essentially layer 1 right here, the frame itself, how big it is, data captured. This is layer 2 of the OSI model, and you can see that we can see a broadcast message as the destination MAC address, and then I see the source MAC address, what kind of network card I've got in my computer there, okay. And then I've got layer 3 of the OSI model, which is your logical information, the IP address information. And then layer 4, there's your UDP or TCP. In this case, DHCP is all powered by UDP. It's an quote-unquote unreliable or non-acknowledged protocol. And then we have the application data itself. Okay, so I was going back to creating a filter, right? If I just want to see DHCP requests, well, truth be told, the old name of DHCP is actually Bootstrap. That was before it got nice and pretty name of DHCP. So still behind the scenes, you see this Bootstrap protocol. So I can right-click on that, and I can say, I want to apply that as a filter to the selected. Now, what do you mean selected? I mean, I clicked on Bootstrap protocol. That's what's selected now. Apply as filter for the selected. I can also say, not selected if I want to see everything but DHCP. I mean, there's a lot of ways you can approach this. So I'll just say, give me the selected. Oh, look at that. Now, doesn't that trim it down? So right up top, now I can see exactly what happened when I went through my ipconfig stuff, right? First off, I had the DHCP release. That was my ipconfig release. So that was my computer, there's the source, telling the destination, which is the router. Matter of fact, if I expand that out, I can see there's my source MAC address. Now, hang on, take a look at this. It's a C86000. Okay, I go back here. Go back to my ipconfig/all output, right? And right here is the physical address. See that? of my LAN detector. See any similarities between that and what it actually captured? Again, it's the same thing. So I can look right there. This is the my computer essentially is the source address. I can even expand that out and say, give me more details about the MAC address. Destination is my router, which actually is a Ubiquiti router, and there's its MAC address. And I say, well, okay, what's inside of there? I can expand Bootstrap, and I can say, okay, well, it actually went through and said I want to release. Now it's buried somewhere in there, but I can see right here the info is DHCP release. If you want to expand all of these fields, you'll actually find out one of them. There it is. DHCP message type is release, and I can see that I'm giving my back. Now from there, I did the notice. So this is at 17 seconds into the capture, 28 seconds into the capture. So about 11 seconds later, I typed in the command ipconfig/renew. Now my computer, which has no source address, so it's all zeros, sends out a broadcast. So it's saying, this is just me. Now it still has a MAC address, right? So it has a source MAC address that's burned into the network card. It's sending a broadcast. It's like, hey, hello out there. I'm looking for DHCP servers. By the way, that's what a DHCP discover is. It's like somebody walking into a loud, noisy room and yelling and going, is there any DHCP servers in this room? One comes back. Now look at this. 1 second later, actually almost exactly to the millisecond, the Ubiquiti server responds, the Ubiquiti router, I should say, responds and says, hey, I'd like to offer you an IP address. And we're like, if I'm a curious person, I'm going, I wonder what it offered. So I expand this out and I go, oh, okay. He's trying to offer me 172.30.100.188. Now that happens to be the same IP address that I had before. Now, this guy, again, my client, he hasn't accepted that yet. He's still, like, the DHCP server is like, hey, would you like this IP address? It's tasty and delicious. My computer's like, oh, actually, yeah. I kind of want that. Well, looking at this, you'd be like, well, how would you know? So take a look at this. Discover's like, hello, any DHCP servers in the room? DHCP server comes back and is like, oh yeah, I'm out here. Matter of fact, I have an address for you. Then it comes in and says, well, I would like to request an address. Now, this is a little confusing at first, right? Because you're like, okay, he still doesn't have a source address, and he's broadcasting it. So he's not responding directly back to the DHCP server, which is 172.30.101, right? He's not saying, oh, okay, thanks, buddy, I'll take your offer, right? No, he's broadcasting. He's like, hey, I'd like an IP address. Someone, can you give me an IP address? But watch this. When I expand this out and I go, okay, well, let's dig into what's he really saying. And I look and I go, okay, well, it's saying that if here, let me see if I can shrink this down. I think I've expanded it all already. Yeah. Oh, well. Well, you can see that option 50, this is, again, in the nitty-gritty packet details that we would never know just by looking at the summary up here. It is actually saying, broadcasting to everybody, hey, everybody, I would like an IP address, but I'm actually requesting that whoever offered me 172.30.188, that's the one I really want. Right? So if there were other DHCP servers on the network saying, oh, I've got your 172.30.150 over here, he'd be like, no, actually, I'm kind of preferring this one. So if the DHCP server who offered me this could please step back up and respond, I'd be very grateful. Well, you can see, look at this, almost less than like half a millisecond later, if you're looking at that time, the DHCP server is like, I gotcha, got it right there. Matter of fact, here is your new client IP address. Congratulations, you are the winner of this IP address. Congratulations, here you go. And then you expand it down. It says, oh, by the way, I'm also going to let you know that I am your DHCP server. You see option 54 right there. It says, you can hold on to this IP address for 1 day. That's the least time. So, I mean, you see all this good info that you get digging into this stuff you would never see. Oh, by the way, here's your subnet mask. Here's your default gateway. Here's what DNS servers you should be using. I mean, all of this coming from the DHCP server, right? We just see DHCP request reply, but when you use Wireshark, wow, you can really dig in. And then you find out, again, sometimes you may not see this in a book, but you find out, okay, the client now gets it and then broadcasts to the network a DHCP inform message. What is that? It's a broadcast letting everybody know, hey, everybody, I've got this new IP address, 172.30.100.188. Why is it doing that? Because it wants to know if anybody else has that address. See, notice the destination is all 255s. That's a broadcast. He's trying to say, hey, if anyone else out there is using this IP address, I want to let you know I've been assigned it. right? So if there is another device out there, let's say, this server over here is like, hey, whoa, 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 wait a sec, that's me. By the way, that's what causes you to get those messages in Windows that says IP address conflict detected, is because somebody did a DHCP inform letting everybody know this is their IP address. So he comes back, he's like, hey, that's mine. Then this guy's going to go back to this DHCP server and be like, whoa, what's up, buddy? You're giving me an address somebody's already using. And if it's a good DHCP server, it'll say, oh, my bad, sorry, let me remove that from my pool as a quote-unquote conflicted address, and I won't assign that one again, right, until an admin comes in and tells me that's okay. So I know. You're like, how did we get here? Matter of fact, I'm thinking that. How did we get that deep into DHCP services? I don't think I meant to get that deep into DHCP, but once you start opening Wireshark and digging in, just how much good information is there. Now, think of that as a troubleshooting scenario for DHCP. But you could apply that to anything, to voice over IP conversations, to communication between a client and a server that's not working correctly. I mean, all those kind of things can be revealed with Wireshark. Okay, now back to our original objective. It was to set a static IP address, right? So I'm coming back in here. All I need to do is make sure that there is one available on my network. I'll use 172.30.100. This is where my IP address Excel spreadsheet should tell me exactly what is free, but I'm going to wing it and go with 223 because it's a nice odd number that I don't think I would ever assign to a device on this network. So I'll do 100.1 as the default gateway. Now, DNS servers, I'll tell you, it's kind of a no-brainer for me. If I'm just looking for a quick DNS server to use, I use 4.2.2.2 with 8.8.8.8 as a backup just because they're so easy to remember. 4.2.2.2 is actually a DNS server at level 3 out in California. 8.8.8, if I could say that fast enough, is Google DNS. So I'll click on that, click on close, and voila. I have assigned a static IP address to my computer. I can verify that by doing an IP config right there. Now, tool number one. I mean, this should be like the number one tool in every Cisco admin's belt. It is the ping utility. Ping, let me kind of shrink this down, allows you to verify that something is actually up. And again, going back to Wireshark, Wireshark can actually show you what's inside of a ping packet. So if I do, here, let me do this. I'll come back to Wireshark here. Let's clear the filter and do a capture. And let's go ahead and hit start. No save. Okay. I'll do a ping 192.1 or 172.30.100.1. So I'm just going to ping my router. Comes back, it says time is less than a millisecond, which is great, and we're good. So let's go ahead and stop that. And if I scroll down here, I should see, there we go, ICMP. ICMP is the protocol of ping, and you can see that we have echo request and echo reply. So behind the ping name is actually this sub protocol called echo request and reply. It's like sonar. So if I expand that out and I say, well, show me what is inside of that ICMP packet, you can see it actually sends 32 bytes of data, which corresponds with this information right there. It says, oh, 32 bytes is good. I hit the plus sign and I go, okay, well, here's the actual data. Now it's all in hexadecimal. So if I look over to the right hand side, I see a human dump, if you will, and you can see it's the alphabet, A, B, C, D, F, G, H. It just essentially loops the alphabet around to make sure that it gets 32 bytes of data that it can actually send to the other side. So I see the request is that data being sent, and then the reply is that data being sent back over to it. So again, the alphabet, or 32 bytes of the alphabet, is sent back and forth between those devices. Now, pings, I would say, if you told me I have to take all your tools away, Jeremy, except one, hands down, it would be ping. Being able to ping something tells me that I have network connectivity to it. Next up under that is the traceroute command. Now, depending on what operating system you're using, it'll be traceRT in the Windows side, or traceroute in Cisco, like the full name spelled out. Same thing on, I think, some distributions of Linux I've been playing with use a trace path command. So they're all the same thing. Essentially, it allows you to see the devices in between you and whatever you're going to. Ping tells you that you can connect to it. Trace RT shows you every router that you're going through along the way. Now, I always, whenever I do a trace RT, well, let me do this first. I'll do 8.8.8.8, right? Let's go to Google. I usually will do a trace RT dash D. And then the IP address. The reason why is because otherwise it tries to look up every single DNS name along the way, which makes this thing take so long. Now, I'll say the DNS names can be handy because I can say, oh, okay, look at that. I went out through quest.net, so I know, okay, well, so I know I went through that service provider. But then once I left Quest, it looks like I went from Phoenix to, I'm guessing, Los Angeles, just based on that name right there. And now I'm just going through all these IP addresses that Google doesn't have the name for, right? So it's just kind of hanging there. Now watch this. If I do a Control C and hit the up arrow and do a traceroute dash D, it's going to just go right down through. It's not trying to look up the names of what it's going through. It's just going to each hop, and I'm seeing how many devices I'm going through on my way to that Google DNS server. Now, right about here, it looks like I hit a firewall because they're blocking me from seeing who they are. That's a little asterisk. Now, what a traceroute does is actually 3 pings for every single step. The reason this is good is because I can see my slow points in the network. I can say, okay, well, maybe if this one had a ping time of 500 milliseconds, I could be like, wow, that must be my bottleneck along the way. Now, you can see that somewhere in the middle, likely when I got to Google, they blocked me from seeing their outside device using a firewall, but eventually I see that I got to 8.8.8 itself. And if I ping 8.8.8, if I could type it in right, there we go. Notice that I have a ping time of 71 milliseconds on average it takes me to get there, and that corresponds with this. So I can say, okay, as I get further and further on through the internet, now I don't know, and by the way, there are visual traceroute tools where you can actually find out. I don't know where in the country 8.8.8 is, but essentially it takes my computer 71 milliseconds to get there and back. Remember, this is always a round trip. So essentially, probably takes me around 35 milliseconds to get there, which is crazy fast if you think about it, considering we're probably traveling hundreds or thousands of miles, and then 35 milliseconds for that data or the alphabet to get back to me. So that is traceroute. Now ARP, moving on to my list. Now, who remembers what the ARP command does? It translates from IP address to MAC address. So I was going to say you won't use ARP that much, but I'm like, I've actually used this more than the average bear. ARP can be a very handy utility when you are doing, I would say, any kind of network maintenance, right? So here's essentially the process to make sure everybody's familiar with it. Let's say I've got a computer connected on a network to a router, which in this case, maybe this is the 172.30.100 network that I've been working on so far. This is the .1 IP address. I'm what did I say, 232? One of those IP addresses. But essentially, whenever I get off my network and I'm saying, okay, I want to leave here and go to 8.8.8.8, which is Google's DNS server, right? It's going to go, oh, that's not my network. I need to go out my default gateway. I need to go out my router to get there. Well, it's going to need its router's MAC address, right? And the way it's going to get that is using ARP, Address Resolution Protocol, which is a broadcast message saying, hello, I need to find out what the MAC address is for 172.30.100.1. This guy replies and says, here you go. Now, here's the thing, and I don't think I've said this up till now in the series. ARP will cache that. What that means is it will remember it by default for 5 minutes of idle time. So let's say that this router dies, or I'm replacing this router, or something to that effect. I put a brand new device on the network and move the internet connection over here, and I say, okay, well, I want to make this as seamless as possible, so I'm going to unplug this cable and then plug it into here, which has the .1 IP address on here. Well, the problem is this guy will have a new MAC address. And this computer over here will still have cached for 5 minutes the ARP message, or I should say the MAC address of the old router, which I'll label right here. So the problem is now when I do this, I've caused an internet outage for everybody for at least 5 minutes while they're waiting for their ARP message, or their ARP cache, I should say, to time out before they'll send a new ARP reply. So the ARP command in Windows and on Cisco, you can type in show ARP in the Cisco world, allows you to see a whole bunch of stuff about those MAC addresses. So I can type in ARP -A to display the ARP table, and you can see 172.30.100.1 has this MAC address, and so you just see this table of this mapping all these MAC addresses mapped to these IP addresses, or actually I should kind of flip that statement. All these IPs mapped to this MAC address. If you're troubleshooting, like take that situation I just drew up right there, and I want to be able to clear the ARP table, you can actually clear an individual entry, but I mean these things rebuild so fast. I just do an ARP -D star, which wipes them all out. If I do an ARP/A, you can see there's nothing there until my computer, I'm sure behind, well, okay, let's ping it. Let's ping 8.8.8.8. It's being very quiet. Behind the scenes goes to access something. Now I do an ARP-A, and I can see, whoa, it resolved the IP address of the router. It had to use that to reach this network. So ARP-A again, oh, it looks like it's resolved another one. Why? Because 172.30.100.25 is actually a server that I'm connected to where I store these recordings that I'm talking to you on right now. So it's probably checking to make sure that's available. As a matter of fact, I have the window open in Windows Explorer, so I'm sure it's checking in. So as I'm sitting here, the more that I do on this network, the more I'll resolve. Watch this. I'm going to do a ping 172.30.100.255. What is that? It's a broadcast network for or the broadcast address, I should say, for my network. And whoever replies fastest is the one that actually shows up as the ping result, which is .9. I don't know who that is, but they're out there. But when I do an ARP-A, take a look at this. All of a sudden, I've built this giant MAC address table with all these guys. Why? Because they all replied. Even though this guy was the fastest, all these other devices replied to my broadcast ARP message, or my broadcast ping message, I should say. So my computer is like, oh, well, hey, if they're replying to me, I might as well cache their MAC address. So that's kind of a cheesy, quick way of finding out what other devices are sitting there alive on your network with the ARP command. All right, last command, NSLOOKUP. It's funny because I keep thinking I'm trying to move from most valuable down to less valuable, but the more I go through this list, I'm like, good grief, how can you survive without these tools? I use NSLOOKUP all the time as well. NSLOOKUP allows you to query a DNS server. So, for example, I'm saying, well, I want to go to, let me just go this route. Let's say I open a web browser and I go right there to google.com. Right? Or I go to cbtnuggets.com. And I'm saying, well, I wonder what IP address I'm getting for that. Well, one way that you can do it is you can say, I want to ping cbtnuggets.com. Comes back and says, this is the IP address. Now, CBT Nuggets is blocking ping messages, so even though it's timing out, I know that behind the scenes, CBT Nuggets actually has that IP address. But I might wonder, well, I wonder if they have any other IP addresses, or I might just want to start getting a laundry list of IP addresses. I'm trying to think if I should even, now I'll tell you this one. I'll do NSLOOKUP. First off, show you the base utility. It says, okay, I am using this as my DNS server. So I can say, well, show me what cbtnuggets.com is. Comes back and says, oh, okay, there it is. One IP address maps to cbtnuggets.com. I might say, well, I'm curious. Is it different for www.cbtnuggets.com? It goes, oh, well, actually, yes, it is. cbtnuggets.com goes to a web balancer at amazonaws.com, which is actually load balancing those between these two IP addresses, one of them which happens to be this. So you can see that CBT Nuggets is actually, if I were to open a web browser, I mean, this is just good information, and go to cbtnuggets.com, I'll only have one server that I hit. Oh, and it looks like they redirect me to that. But if they would allow me, there would only be one server, whereas www is load balanced between two servers. I wouldn't know that if I didn't use NSLOOKUP. Likewise, I might be waiting for DNS replication to happen on the internet. Maybe I changed. Maybe I got my own domain name, jeremy.com or something. And I said, I'm waiting for that to replicate. I can actually change DNS servers. I can say, well, I want to jump over to the server, google.com, and I want to see what it thinks jeremy.com is. And I don't know what jeremy.com is, but obviously that is the IP address associated with jeremy.com. And so I can change the perspective all over the place. I can even, for instance, say I want to set the type of records that I look at. Now, I'm kind of going off a little bit, but I'm telling you, as a Cisco engineer, you will be expected to know these kind of things. Set type equals MX. What is MX? It is a mail exchange. So I want to know where email is being sent for, let's just say, cbtnuggets.com. And I look and I go, okay, well, it looks like, well, I mean, look at this. They have all these redundant email servers, and all of it's going to Google, which immediately tells me, and I know this to be true behind the scenes, that CBT Nuggets uses Gmail to host all of its email. That's the email hosting service that they're using, right? So NS lookup can be and by the way, setting it back to A is the address record, so I can go back to my base queries of cbtnuggets.com and find out what IP at. Huh. That's interesting. Oh, wait a second. Okay, we're load balancing, right? Is that the second? Okay, that is the second address. I was thinking, wait a second. Just a second ago, that wasn't what it was. But you can see that, I mean, DNS load balancing is doing what it does. So that's a very handy tool to be able to do quick lookups of name to IP address mappings. All right, well, let me clear off all the chicken scratch. I know it's only one slide because we're sitting in the live interface for the entire nugget, but I hope seeing those tools really gives you a mind's eye view of how you can begin using these tools to troubleshoot a network. I was trying to give some on-the-fly examples, but as we continue throughout the rest of this series, I'll be pulling these tools out quite a bit to do troubleshooting, to do testing, all of the things that a typical service provider engineer would do. Well, I hope this has been informative for you, and I'd like to thank you for viewing.